Welcome back, everybody, to VMware Explore 2024. Thank you all for joining me. You are here at the right session, unlocking vGPU power from CODE vCenter plugin. However, I made a mistake. I bit off more than I can chew. So, this was going to be, yes, from code to API, because you could still do really cool things with an API. It gets worse. It gets worse. So, real quickly, let me introduce myself. My name's Tony Foster. I work at Dell Technologies. I'm a technical marketing engineer, basically. So, all those fun white papers and stuff you see come out, oftentimes they go through me. I am also known as the Wonder Nerd, hence the cape. So I'm a Wonder Nerd. I do all sorts of crazy things. Sometimes it makes you wonder, is that guy really saying? Sometimes you wonder, wow, can that actually be done? Well, as I said, I made a mistake. This is not the highlight of my career. I will tell you that right now. So everything was working well until I touched down on Saturday. Plugin broke. So we're not going to talk about the plugin. This morning, everything's working perfectly. I go and make one little change to my API stuff so that y'all aren't seeing the credentials to log into my vCenter. And all of a sudden, API breaks. So my API is no longer working. I'm like, okay, well, I can still show them a video of what the code's going to do and how it's going to function and what they'll see. Yeah, no, that decided to break too. And I had absolutely no idea what happened. So we're going to talk about all of those learning experiences here today instead of what this actual plugin is supposed to look like. Because I was really excited about sharing all of this with you, and no. So, the agenda. When we were looking at this as an API, was an overview of what vGPU resource harvesting is and why it's important. So we'll still touch on that, even though I've done those quite a bit. What an API is and why it's needed. How you go about building a Python API. It's actually really simple, except for a couple of things. And we'll talk about that here in a second. Some do's and don'ts. And it jumped ahead of me. I apologize. The fact that this API, and I will have an API up after Explore, it should be up next week. Once I go through and find out where this nasty little bug is, or what update I applied that I didn't know I applied. Anyway, this API is for internal use only, and we're going to talk about why that is. So with that, let's talk a little bit about vGPU resource harvesting. Why on earth would anyone want to harvest vGPU resources? And this is the impetus of the plugin. Well, here's a graph of what a typical environment looks like that's running VDI. You'll notice here on the graph that a lot of people are logging in 7, 8, 9 o'clock in the morning. Go through, we have a little bit of dip at lunch, and then everything tapers off about 1900 when everybody goes home. That means you have about 10, 12 hours in there where your GPUs aren't doing anything on those machines. So the question then becomes, why leave those GPUs idle? Everybody's clamoring to do AI stuff. Everybody wants to have opportunity to grab those resources, train their models, run their AI code, make pretty pictures of cats. Everybody wants to do that. And so that's where the idea behind resource harvesting comes into play, is let's grab back those resources. That way, when we have idle host, we can go in and grab those resources and consume them. And as our idle time drops during the day, we release our resources back to the rest of the environment to run VDI or whatever workload is our primary workload. So as you can see with the little table here, we've got how everything works out idle host-wise and everything. And this is allowing us to reclaim resources. And so that's what this plugin is going to do. I have a set of PowerShell scripts that already do this. You can find them on my GitHub, github.com/wondernerd. And all of this is coming up in later slides, so yeah. But github.com/wondernerd, you can find PowerShell scripts that do all of this. This is all done in Python now. I've gone through, I've updated it. I've added a lot of features and functionality for 8.0 in Python, including mixed GPU workloads on the same GPU. So before, you used to only be able to run one vGPU type on a GPU. Now you can run multiple different profiles on a GPU. That came out in 8.0 update 2, what was that? G, I think. So anyway, that capability is now built into this. So let's talk a little bit about APIs. I think most everybody here is familiar with APIs. If not, please raise your hand. And nobody raises their hand. Cool. So the idea is we're putting an API in front of all of this. That way, since I can't get the plugin working for y'all, you can at least go in and build your own web UIs and stuff to control this. Because the feedback I kept getting on the PowerShell scripts is, Tony, these are great. However, I have to run a PowerShell script and stuff. I don't want to run a PowerShell script. I just want to have a plugin where I can go into my vCenter, single pane of glass. There's where everything's going. I can see how it's balancing and everything else. Easy enough. So I thought, not really. So went for the application interface. Still can build a web application for it. Still pretty cool. And why do we want this? It provides us extensibility. So not only can I sit there and use it in vCenter, I can also go out and use this API wherever I want to run it. So maybe I want to set this up so users can do a self-service portal. And they can sit there and go, I want to register my environment into this so that it can get some of these resources. API's got you covered. So that's the reason why. We want to make this extensible and make it as accessible to as many users as possible. So doing this, it's actually really straightforward putting together an API. I don't know how many people here have built their own APIs before. I got about 3 people who have done it. So this tutorial up here is an absolutely phenomenal tutorial on building your own API. Walks you through it real quick, uses really clean language and everything on how you go through and do that. Gives you all the step-by-step instructions. And this is what I followed. It works fantastic, except for a couple of things, and we'll come to those in the next slide. Then you're going to create a Python virtual environment. That Python virtual environment is going to plug into your Flask environment. It's going to be part of your Flask environment. And all your code's going to run inside of that Python virtual environment. Part of the reason for that is security. You want a sandbox so that people aren't potentially breaking out of your Python environment unbeknownst to you through some bug in Python and getting into the rest of your system. So Python virtual environment, python.org has some nice additional material that goes along well with the REST API and Flask one up above. And then you're going to need, of course, PyVami and the vSphere SDK. You need both of those. You can't do it with just PyVami. You can't do it with just the VMware SDK. You got to have both the vSphere SDK and PyVami, because you wind up making a lot of calls that rely on both, especially your authentication and stuff, which is very heavily geared towards the vSphere SDK. And of course, you'll be able to find all this material on GitHub here after the conference, when I have a chance to troubleshoot and figure out what went wrong. So, workload balancing. It was going to be real simple. You pass it a JSON file or a JSON string with your parameters in it. Those parameters being what virtual machine base name you have for both your primary workload and secondary workloads, what extension on the end they have, so like 000, whatever their padding is, you put that in there, and how many secondary workloads you have, what number it starts at, and your authentication, away you go. You push it, that little command does it, it comes back and says, here, I've balanced your workload. That simple. So it was going to be really simple, really elegant, and we'd spend time talking about the code up here. Unfortunately, I apologize, we didn't get that done. So what happened was I was working with a plugin, and there's a very nice tutorial that I found that makes it real simple to do plugins. I managed to lose the bookmark. I lost the bookmark. Cannot find it now, cannot find it in my history or anything. And so I could not find the simple way to make plugins. If you are interested in plugins, there is a very long, elaborate way to make plugins from VMware. There are about 30 steps of getting certificates and security keys and everything else. I don't want to go down that journey first. I want to make sure that it works. So anyway, that will be coming soon. Probably in a month or so, you'll actually see a plugin pop up on my GitHub where you can actually work with the plugin and see all this stuff inside of your environment. Because beyond just the workload balancing, I built in a lot of other functionality into the script where you can see your GPUs and expose a ton of the stuff that is in the mob. And I'm, again, guessing everybody here knows what the mob is. So managed object browser for vCenter, I spend a lot of time in there, which gets us to next error. Let's see. So next error that I ran into, and I spent a good chunk of time on this because I was getting really weird results. Inside of the vSphere environment, you obviously have your clusters, your host, all your virtual machines, and inside of your physical host, you have your physical GPUs. Those are all objects you can work with. The GPUs actually have an option so that you can see what virtual machines are running on them. I use that extensively in my code. I discovered on Saturday, one of the bugs that I was fighting is that that does not refresh as fast as just resuming a virtual machine. So you go and resume a virtual machine, that location information does not update on the GPU as fast as it updates in the rest of the system. So you'll have two different states in your environment on there. So I've got a bug to find there. Now, there are a couple of limitations. I haven't hardened access to any of this. So this is for lab use only. You take it, you use it only in your lab, because your passwords and everything are still fairly clear text. I'm not doing any calls to get API sockets or anything on those yet. That's coming when I get the plugin working. So lab use only. There's no emergency brake on this either. So one of the things that has been asked for before with this plugin is the ability to, if something goes haywire, if my executive comes down and goes, oh my gosh, performance stinks, what are you doing? You can click a button and literally stop all of the workloads so that your primary workloads can come in and take over. The code is also not optimized. There are some very slow spots in the code. I am aware of it. It's not bad coding or anything. It's just like, hey, this is a very efficient way to do that, at least code-wise, not when it runs. So it's not optimized there. It is not multi-threaded yet. So those are all things to be aware of. Error correction and detection. There's actually a lot built into this. There's still more that needs put in here to detect the wonderful random things that can show up from users. But it's pretty good on names, profiles, strings of any shape, size, and type. There's a lot of stuff actually built into the code to make sure it comes out right. And then there's the object bug that I told you about where stuff doesn't update as fast as it should. And if you look in the mob, you can find the GPU information underneath your host, config.graphicsinfo, and that'll bring up all of the GPUs in the given host. So, a couple more limitations. Oh, and forgot, my bad. There's a screenshot from the mob with the wonderful object at fault. So, some do's and don'ts. Please keep this in the lab. Use a separate account. Obviously, don't use your administrator account. I don't think anybody would want to go through having that just broadcast willy-nilly. Careful with the debug and error messages. There are a lot in there. The code for this is about 800 lines of code. If you go through and uncomment the debug messages in there, that's about 2/3 of the actual code. So yes, I like to comment my code. I like to leave the debugs in there so people can actually follow what's going on and can see it trip along. And I want you to have fun with it. So my apologies to everyone. This is not what I was intending to present today. I wanted to bring you something awesome and go, here, look what you can do inside of vCenter. So, like I said, this is one of those where you probably wonder, what's up with this nerd? Not, wow, look at what that nerd did. So, I thank you for your time. I'm going to go ahead and open it up for questions, and we'll tackle as many questions as possible. And also, just to entice you with questions, Frankie hooked me up. I got tokens for a t-shirt for people who want to ask questions. So. I'm sorry?
Are you only using the vSphere API, or are you also using operations or Horizon?
So I'm actually sticking just inside of the vSphere API, and there's actually a reason for that. This can work for something other than just VDI. So if you have two workloads, you can actually mesh those two together and just go, workload one runs, that's my primary workload, and let the other workload kick in when resources come free from the primary workload. So there's actually a while loop that just sits there and monitors the environment, and you declare a spare amount. So I want to make sure I have capacity to fire up 3 primary virtual machines. You start up 3 primary virtual machines, and it's going to maintain 3 spare primary virtual machines, making sure you don't step on it. And I can show you a demo of that after we're finished here. Yeah, so there is a token. You can use that to get a shirt. Yes, sir. So this would be a one-time run. You'd put it inside of a virtual machine, and originally that virtual machine was going to be my plug-in virtual machine, but it'd sit there and run on a virtual machine. You'd set up a cron job just to sit there and fire it off at a given period of time, and it'd sit there and run. So awesome. Thank you for that question. Yep. Yes, sir. I'm sorry, could you say that again? GPU compression? Oh, for production or compression? So right now this code can't be used in production. I strongly recommend not using it in production. If you go through and make some tweaks, it can definitely be used in production, but there are enough security things that I am very well aware of that I definitely could not recommend using this in production. And Frankie, could you get him a chip, please? Yes, sir. So the question was, am I just distributing the source code, or is there a container version of this? Right now, it is just the source code. Eventually, there will be a virtual machine, and sometime in the spring, I will probably get a container built. Frankie, could you hook him up with a, yes, sir. Yes, it is applicable to instant clones, because instant clones show up as virtual machines inside of vSphere. So, here you are. Any other questions? Oh, yes, ma'am. So the primary use case for this is with VDI environments, where you have a big dip at night when virtual machines go down. Not in production right now, yes. Cool. Okay. I think we are at about time. Oh, cool. Okay, what do we got, Frankie?
We had a change in schedule. So I know that you told somebody here that you wanted, maybe afterwards you were going to do a demo.
Yeah, no, I'm not going to do a demo up here. I'll do it offline. Thank you all for coming. I greatly appreciate it. Please don't forget to take the survey.